All right, so we are talking a little bit more about that ESCI output and how we basically got it. So, as I kind of showed you before, the summary statistics that I pulled up are shown for you in at red 3 right here. The individual values were found here. So if we want to examine those comparisons again, we're going to pick two radio buttons. So we're going to pick our neutral content versus our violent content. The comparison and the confidence interval on the difference will be right here. And then the actual values of our effect size and the confidence interval are going to be shown right here, along with the margin of error, degrees of freedom, and for those who would like it, a p-value. Okay, so here are some basic assumptions that you need for a one-way independent groups design. So first of all, the samples have to be independent of each other. That basically means that you can't have somebody being in multiple groups, for example. So the samples have to be independent. You don't want the same person in two different groups. That would thus ruin the independent observation. Additionally, each should be a random sample from a normally distributed population. Additionally, we're always going to be looking for that homogeneity of variance. The population underlying each sample should have about the same standard deviation of sigma. To basically assume homogeneity of variance, we want to make sure, and I've kind of told you this rule of thumb before, this is true for pairwise comparisons in our two-group between groups designs. The largest standard deviation should not be 2 times larger than the smallest. So we want to make sure they're within that range. So let's say, for example, that we wanted to look at other types of things. So, for example, if you end up getting a bad test grade, would you be, and I gave you some positive encouragement, what would end up motivating you more? Something that's comforting with a message of positive encouragement, positive encouragement that challenges you. So either comfort, challenge with that positive encouragement, or a control condition where you just got the positive encouragement. So the comfort would be like, there, you're a great person. I know you can do this. I'm sorry you're having trouble. So that would be the comfort aspect. Challenge would be, look, I know you can do this, but you need to step it up. You need to work harder if you want to end up doing well. And then finally, the control is basically standard positive encouragement. You can do this. So maybe I'm kind of interested in the role that comfort might play versus these two conditions where comfort is not involved. So if I want to look at the difference between two means, such as comfort versus a challenge, that's what we would call a comparison. But if I want to look at comfort, statements of comfort versus no statements of comfort, I'm basically comparing this mean compared to these two. And at that point, we are no longer doing a comparison, we are doing what is referred to as a contrast. So this is what is called a subset contrast. So we're basically going to be comparing two groups of means here. So a subset contrast is basically the mean of one subset of means minus the mean of another subset. So here we're going to get an average based on both of these two groups and compare it to this one. So this actually comes from work based on people like Carol Dweck, who believe in the power of mindset, and Ratton, basically testing student motivation in response to feedback. So students had to imagine that they received a low grade on a math quiz, and I know what some of you are thinking, Dr. G, I've been there, and some of you are like, that would never happen to me, I'm good at math. So they got one of three types of feedback. In a control condition, they got simple positive encouragement. You can do this. In a comfort condition, they got that positive encouragement plus reassurance. And then in the challenge condition, they got positive encouragement with a challenge. So if we want to look at a subset contrast, we're going to have to do something a little bit different. We're going to go to a page called Independent Groups Contrast. So let's go ahead and take a look at these in ESCI once again. So we're going to go to our page called Independent Groups Contrast. Now in this case, we need to pull in different data. This is another type of data that we will be looking at later, but I want to look at this data. So I'm going to go ahead and transfer that. I'm going to replace any previous data. So it's taken its sweet time. So notice that because I transferred that data, we have now changed from 6 conditions, which we'll talk about in a minute, to 3. So in this case, you are not going to have radio buttons. You are basically going to be comparing these 2 conditions. So here are our summary statistics. So here are the number of people we have in each group with their means in terms of motivation. Our standard deviations, notice that they're all relatively close to each other, so this would fit our homogeneity of variance. Here are the individual confidence intervals and margins of error for each group. And then here is our full data for all parts, but are interested in these contrasts. So basically, we're going to create a subset here. So in this particular instance, we are going to create a subset. I'm going to go ahead and, since I already know that these 2 groups, that these 2 conditions are higher than our comfort condition, I'm going to go ahead and make them my top subset. So notice here's their individual data. Now watch what happens when I add them to my subset. So here's the mean of our 3rd group right here. So 4.44. So that is our control group, which is right here. So notice that it basically is what's reported over here. Now watch what happens when I add the challenge group to it. So we do that, and notice that we now have a subset mean. So here are my 2 groups, and I've created a subset. Notice that my confidence interval has gotten smaller because I've averaged these 2 groups together. And then we're going to compare that to our other subset. So take a look at our data. So here, notice that our subsets, we can do a comparison between these subsets. They don't touch. Odds are pretty good. There is a significant difference here. And when we pull up the p-value, it is 0.002. So notice these still aren't touching, and that's really helpful. Here is our confidence interval on the difference. Our effect size basically says that the effect size is about 1.5. So basically, getting positive encouragement or getting positive encouragement with a challenge. And really, I'd argue it's this challenge in particular that tends to be more motivating. In this particular instance, notice that that leads to a 1.5 increase in motivation. Now, the confidence interval can range from a 0.58 increase all the way up to a 2.46 increase, indicating that positive encouragement with reassurance isn't really as effective as challenging or just the positive encouragement on its own. So that is very, very interesting, and this is how we would do our subgroups. So if I wanted to look at the difference between positive encouragement on its own versus positive encouragement with other things, we could create a new subset. So let's have our challenge group and our comfort group. They're going to be our own subset. Notice that when we combine these 2 this way, look at how low that is. If we compare that to our control condition, we've got our subset analysis. Notice that all of a sudden, there's not really much of a difference here. And I'd argue that once again, if we got rid of our comfort condition, odds are pretty good, we would not get that effect. So notice that there's no significant difference here, and the confidence interval on the difference, notice how broad it is, and it covers all possibilities. It kind of bears that out. So let's get rid of the comfort condition. So now we're just doing a simple comparison. We're not doing a subset contrast. All of a sudden, you can kind of see that there is a difference, but it's not very large. So in this case, a subset contrast tells us something that's significant. This is marginal, and you know how I feel about the word marginal. I'm saying if you're calling it marginal, it probably isn't. So here are some different ways that you can kind of explore with your data. So I'm going to go ahead and close out of that because we're going to need our subset contrasts for something else next time. So now that we have this, so we did this subset analysis. So we're going to do a contrast of comfort versus challenge and control condition, as I showed you. The difference is basically displayed as typical comparisons. We basically combine challenge and control into one mean. The contrast between this suggests that feedback, including comfort, prompts ratings of motivation toward math that are about 1.5 units lower than other groups. So supposedly, if we want you to get better at math, I'm not supposed to go, oh, there, it's going to be okay. What I need to be doing is, you need to work harder, or just simply, you can do it. But it's kind of the same idea. This is how a contrast works. So now we're going to try one more, and this is where that 6 different groups came from. So there's been a lot of talk about what could potentially be a precursor to Alzheimer's disease or what could potentially prevent it. Now, one of the interesting things that I've always heard is that you could potentially think of Alzheimer's disease as type 3 diabetes. So a lot of people who end up developing Alzheimer's disease, they have issues with their blood pressure, issues with their cholesterol, problems with their diet and their blood sugar that could potentially lead to atrophy, the characteristic atrophy that we see in Alzheimer's disease in later life. It's part of the reason why I started kind of jumping off the deep end and eating a little bit healthier these days is just because, well, I don't want this to happen to me. So Halagapa and colleagues basically looked at whether or not Alzheimer's could be delayed by restricting diet. So basically, we've got Alzheimer's prone mice. These mice have a gene. They will basically develop dementia at some point. Rather, it won't look like Alzheimer's in them, but they will have neural degeneration that looks very much like Alzheimer's. And so they were compared to control mice in 6 different groups. So here we have our normal mouse. Here we have our Alzheimer's type mouse. Some of the mice were on a restricted diet. Others ended up eating freely. So here we've got normal groups of mice, Alzheimer's prone mice. Both of these are eating freely. Here we have a prone mouse on a diet. And then we also, the researchers also tested mice at what is considered middle age for a mouse, which is basically 10 months, and old age, which is basically about 17 months. And because these are all in different groups and the mice were not, so all of these groups of mice were separate from each other, this would be a case where we've got a one-way design where we have 6 different groups. So here is each of the group labels and their means. So here's kind of interesting. So cognition in mice was basically measured as the time near a target of a water maze. If you've had me for biopsych, you know what that water maze is. A mouse is put in water and they have to basically swim around a platform that usually has a target, a visual target near it. Now there are a lot of groups here. And because there are a lot of groups here, a lot of different comparisons are actually possible. One of the things that your book actually notes that we'll kind of talk about a little bit later is that when you have 6 means, there are up to 286 different contrasts that you can do. Because we have a lot of groups, there are a lot of different ways that we could break this down and compare them. So this is where planning is really critical, because you are not, A, you're not going to have time to do 286 contrasts, and B, some of this is going to be relevant for what you want to look at, but a lot of it won't be. And finally, the more of these contrasts you do, the greater the likelihood that you're going to find something that looks significant or meaningful, but it's random. And the more contrast that you do, the greater the likelihood for that type 1 error increases. So let's talk about what we can do. So we're going to compare middle-aged versus old groups of mice. So let's go ahead and see if there's a difference there. So let's go ahead and open up our ESCI one more time. We're going to go to our chapters 10 through 16. And this time we're going to go into our independent groups contrasts. In this case, we're going to do two different comparisons. So let's go ahead and go to our independent groups contrasts. We're going to create a subset. So we want to, first of all, maybe you're interested in an age difference. So here's our data. Here are the means, time near target for the mice. And then here we have our different groups. So we have our different labels. I can't really see the labels, so I'm gonna kind of zoom out, however briefly. So here we're gonna compare our groups. So we're gonna look at our 10-month groups versus our 17-month groups. So notice kind of what I've clicked, and I'll zoom back in here for you. So here we've got our middle-aged mice versus our old-age mice. And you can see that even between the groups, there's a lot of variability here. And so because of that, you will notice that our confidence interval has a pretty wide range. Additionally, if we take the p-value for it, it's not that significant here. So in this particular case, we find that the middle-aged mice really don't do all that different. The old-age mice aren't really that different from the middle-aged mice. And in fact, in some cases, they might even be better than some groups. But ultimately, what you really need to notice is that these confidence intervals overlap very readily. And so because of that, our confidence interval on the difference actually does briefly run into the negative and also includes 0. So even though it's more toward the side of having an advantage for our middle-aged mice, you can't necessarily make that claim. The confidence interval on the difference is far too broad. But maybe you're not that interested in age. We're not really getting a large difference here. Maybe what you're really interested in, and what you should be interested in, is looking at our Alzheimer's prone groups. So we need to look at our Alzheimer's prone groups and basically see if a restricted diet is more helpful and delays Alzheimer's relative to a free diet. So we're going to look for our comparison groups. So I'm going to go ahead and pick a diet 10. So that's our Alzheimer's group that got a diet. And then I'm going to compare that with, a diet 17. So there is our diet group. That looks really good. And notice that our mean is about 39.75. Here's the confidence interval for the subset along with its margin of error. Now let's go ahead and look at our free diet. So that's 2 and that's 5. Check that out. They don't touch. And so in this case, when we do a subset comparison only for Alzheimer-prone mice, which were on a restricted diet, and in this case, that would be our group in green. Compare that to our Alzheimer's prone mice that basically ate freely. You can definitely see that there is a cognition advantage there. The effect size is massive. It is 8.85 with a confidence interval ranging between 3.6 all the way up to 14. This is a massive difference. And check it out. Our comparisons don't overlap. That is significant at the p less than 0.001 level. So this could actually tell us something meaningful here. It tells us that maybe, obviously mice aren't humans and humans are much more complex, but it's part of the reason why sometimes if we're thinking about preventing Alzheimer's, nutrition might be something worth looking into. And I think that's very interesting. All right. So, in this case, does the diet lessen decline in mice with Alzheimer's? Absolutely. So, in the case of looking at old age, I wasn't really necessarily expecting there to be a difference in old age. And because of that, I mean, that's not a really big deal. I'm glad that when you plan out an analysis and you're looking at your Alzheimer's prone group and you find a difference, that's good. You should be specifying what you specifically want to look at ahead of time. And here's why. So a planned contrast is basically a comparison or a subset contrast, it could be either one, that you specify in advance. Ideally, you should be doing this as a pre-registered data analysis plan. Remember, we're still on the side of open science here. We want that. So here are 2 good rules of thumb for a planned analysis. Specify a limited number of contrasts in advance. You don't want to be picking your analyses after your data analysis. You could be cherry picking results. And additionally, because you didn't specify ahead of time, it's entirely possible that because of things like the dance of the confidence intervals and the dance of the means, that you end up getting something that is not actually significant. You end up increasing the likelihood for a type 1 error. So I want you to kind of pay attention to this table below, and it's also in your book. So if the general rule of thumb is basically this, if a study has K groups, you should try to aim for the number of degrees of freedom of separate questions to ask. So in the case of our neutral content, the Bushman study with our neutral versus sexual versus violent content, there's really only about 2 comparisons that you should probably be doing. So here's what we kind of find. If you have 2 groups or 2 conditions, there's only one comparison that you can really do. You just compare the 2 groups. And there's no subset contrasts. If you have 3, you have 3 comparisons that you can make. You can compare group 1 to group 2 to group 3, or group 1 to group 3. And then there are 3 different subset contrasts you can do, 6 in total. By the time you get to 4, there are 6 different comparisons, 19 different subset contrasts, creating 25 in total. By the time you get to 5, there's 10 comparisons, 80 subset contrasts, 90 total. By the time you get to 6, there's 15 comparisons, 286 subset contrasts, 301 in total. So even with just 6 means, there are a massive amount of contrasts that we can examine. If you examine more than the number of degrees of freedom, the thing is that contrasts are not independent of each other. You are constantly using data that is basically not independent of the other data. Here's what I mean by this. And your book mentions this as well. So if you go to page 414, in our mouse study, we compared mean 3 and mean 2, and then M6 and M5. Then the contrast that combined those 2 comparisons. Because the contrast combines the 2 comparisons, it cannot answer a question that is independent of or separate from the questions answered by the 2 comparisons. So the more comparisons you do, the more likely that they're interconnected with each other, that they're not independent of each other. And so because of that, that becomes an issue, and technically you should be taking a bigger statistical penalty. But because these are becoming increasingly redundant, your type 1 error chances become inflated. So for more than 2 or 3 contrasts, interpret with caution. As you increase the number of contrasts, you have a greater likelihood for type 1 error. Remember, it may be red. We have an increasingly larger risk of cherry picking our results or seeing faces in the clouds. So make sure that you are kind of specifying what you want to do ahead of time. So if we're doing an exploratory analysis, so if we have no idea what to expect, this is what is occasionally called a post-hoc contrast. Examples of a post-hoc contrast that you might see are things that are called Tukey tests. And in the spirit of Thanksgiving, I will share with you, I used to call them turkey tests until I realized that Tukey does not have an R in it. And Tukey are these massive pairwise comparisons. Another one that I've actually used as a post hoc comparison is a Newman-Cool's test. Now, after you are done with a planned analysis, it can be really helpful to explore what you're doing. Just be very clear. You didn't specify this ahead of time. You are exploring. There is the possibility that there is a type 1 error and this effect or this contrast does not actually exist. So always be tentative. With a larger number of contrasts, we are at greater risks of focusing on those confidence intervals that might be red due to the dance of the confidence interval. So here are 2 rules of thumb with an exploratory analysis. Draw tentative conclusions for any contrasts that look interesting, and look for greater strength of evidence as the number of contrasts increases. Don't just go with something that happens to have a p less than 0.05. If you are doing a lot of different contrasts, you should be focusing on a much smaller p-value or a much smaller confidence interval. If you're working within null hypothesis testing, that means that your criterion p-value should, I'm going to say it should be smaller than 0.05. But again, your textbook authors are not big believers in p-values, and given the dance of the p-values, even though I'm more inclined towards them, you should always approach them with a healthy dose of skepticism. So we're almost done. We're going to finish up with one-way ANOVA, and I will see you next time.